Alright, so today we're going to be learning about rational exponents, and we're going to be rewriting expressions that involve something called a rational exponent. You had a vocabulary word that was index. It is the number that's on the outside of a root. Okay, kind of like a square root doesn't have a number, but a cubed root would have a number on the outside, the 30. And we can have any number be a root. Okay? So, some different parts. We're familiar with the square root, which means that this has there's an imaginary 2 out front here. We don't actually put it because that's the symbol for square root. But there are other roots as well, like cubed root, fourth root, fifth root. We can do 20th root, 30th root. Everything has a root, okay, every number. The number on the outside of the radical, this is our radical, or radicand, is called the index. It tells you the number of equal factors you are looking for. So for cubed root, I'm looking for 3 equal factors. So for example, the cubed root of 8 is 2 because 2 times 2 times 2 is 8. I'm looking for 4 equal factors here. I'm looking for 5 equal factors here. So number times itself 5 times, that would equal that number. Okay? So, for the first ones, I'm going to show you guys how to do this without a calculator, but then I'm going to show you guys an easier way of doing them with a calculator. Okay? So, what number times itself 3 times, because we have a 3 on the outside, would give me 8? I just gave you that one. 2. Because 2 times 2 is 4, and 4 times 2 is 8. So this would be 2. Okay, so we're going to do the same thing here. What number times itself 4 times would give me 81? We can use process of elimination. Let's try 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay, that was 4 times, that's not enough. So let's go up a number. 3. 3 times 3 is 9 times 3 is 27. 27 times 3 is
81.
Yeah, so then it would be 3. But don't worry, I'm going to show you guys an easier way of doing it. Okay, so now I need to find a number. Alright, so remember beforehand when we had a square root and we had a negative sign on the inside, it is no solution. However, this number is odd. So that means that I can have a negative number on the outside, because when I multiply something 5 times, it can end up negative. Okay? So let's try. I always start off with 2, just to try it out. So we can forget the negative for a minute, and we can just add the negative at the end. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is, and 16 times 2 is, and, I'm sorry, yes, 32.
Yeah.
So that's 5. So it's going to be a negative 2. I always just start off with 2. Okay, now, let me show you guys how to do it in the calculator. So make sure you have a calculator. Everyone needs one. Okay? If you don't have one, you can go grab one. Alright, we're going to type in the number. Make sure it's cleared out. So hit your on button and then clear it off. You're going to type in 125, okay? And we're going to be taking the cubed root. So what you have to do, you're going to hit that, I want everyone doing this with me. So everyone should have typed in 125. You're going to hit the second button, which is the green button. Then you're going to hit the YX button, which is below off, okay? And then you're going to hit your root, which our root is 3. So I'm going to hit 3. And then you're going to hit equal. What did we get? 5. That one was pretty easy because 5 times 5 is 25. 25 times 5 is 125. But we can do it in our calculator. So let's try the next one. So everyone type in 243. Okay? Then hit second. YX, which is below off. Then what number am I typing in for my index? 5. And then hit the equal sign. And what do we get? 3. Okay, now we're typing in 256. And we're typing the second button, so the green button, YX, which is below off, and then what am I using for my index? 4. And then we're going to hit equals. And what do we get? 4. Not so bad, right? However, it's good to know how to do it without a calculator because something like this first problem could be on the EOC on a day that you don't have a calculator. Or even maybe this one, because you can figure that out pretty quickly. But something like this probably is going to have a calculator, you know? It's going to. Okay. So that is finding a radical, or the exponent. So how roots and exponents can be written interchangeably, okay? All 3 of these are the same problem, okay? So my n is my index, the a is going to be the number, and my m is my exponent, okay? My exponent can also be on the outside, okay? Or it can be written as a fraction where you have your index is the denominator of the exponent, and your power is the numerator of the exponent, okay? So if it asks you to write something in radical form, you're going to write it one of these ways, because it has a radicand in it. If it's asking for it in exponent form, then it's asking for it written as an exponent, okay? So let's practice doing some of these. So I'm going to be writing these first ones as a power or exponent form. So we always start off with the number that's on the inside. Okay, so I have my x. My numerator is my root. Do I have a root? Is my x being raised to anything? No, so it's going to be raised to the first power because it's itself. Okay, and then my denominator is going to be my index, which is 5. So this is going to become x to the 1/5. Okay, I always start off with my base, my number, or letter. Then we do our numerator, our exponent. What is my exponent? 2. What is my index, my denominator? 3. So this becomes 5 to the 2/3. So you should be writing this down. So I'm going to be writing my base, my x. Okay. Then my top number is my exponent. What is my exponent? 5. My bottom number is my root. What type of root is this? A square root, so it's a 2. Okay. So this one looks a little bit weird. So let's do the inside first, because let's follow order of operations. We do parentheses first. So I have x. Let's raise it to the 4th, so that's going to be my numerator. What's my denominator going to be? 3. And this still has to be raised to the 7th. Anytime that you have a power raised to a power, you're going to multiply. So when I multiply 4 times 7, I'm going to get 28. And the 7 could have imaginary 1 on the bottom, so then that would be 3 times 1, which is 3. So this becomes 28 over 3. I could have also just, from the beginning, multiplied my exponents and kept my denominator of the index. Okay? Does that make sense? You could have just multiplied the exponents and kept your denominator of the index. Because this exponent technically has 1 on the bottom. So it wouldn't have mattered. Okay. So that's turning something from a radical into an exponential form or exponent form. Now we're going to be turning something from an exponent form or root form or power form into a square root or cubed root or whatever type of root. And it's going to be called radical form. So, or rational, I'm sorry, rational. no radical, I'm sorry. All right, so I always start off with my base. And then I draw my radicand. All right, what is my exponent? 3, because it's on the top, so that's going to go with my x. And what is my index? My 4, so that's going to go on the outside. I could have written the 3 on the outside with parentheses as well. It doesn't matter, either way. Okay, now here, is this 1/3 affecting this 5? Is it touching the 5? No, it's not touching the 5. Is it in parentheses, like how this one is? No. So that 5 is not part of the root. It's on the outside, okay? Because it's being multiplied. But 5 is multiplying by y. So we're going to have 5 on the outside. I'm going to have my root and then my y. Now what is my exponent? 1. Do I need to put a 1? No. What is my index? 3. So it'll be 5 on the outside because 5 is still being multiplied there. Because it's a number next to a grouping symbol. So it still has multiplication. And then it's the cubed root of 3, of y. Okay, about this one, the 3 is in parentheses. So it is being affected by the 2/5. So all of this, the 3a, needs to go inside of my radicand. So I have 3a on the inside. All right, what is my exponent going to be? 2. So that's going to go on the outside. Because it affects all of it. We have to keep our parentheses. And then what's my index? The number that's on the bottom, 5. If you do not put the parentheses and put the 3 on, or the 2 on the outside, then you only put it next to the a, then it's only going to say that a is squared, that 3 is not squared. So that's why we have to put it in parentheses. Yes.
Did you have to take out the years?
What? That's an A. I just accidentally wrote.
Oh.
Sorry. I didn't that all messed up. So that's turning something from a radical to a power or exponent. And then our bottom one is turning a power into a root or exponent into a radical. Okay? Now, when we're evaluating rational powers, that's what we're going to be doing now, is evaluating rational powers. So, the first thing that you need to do is convert the power to a root. Okay? So if it's as a power, we need to make it into a root. And then we're going to evaluate like we did in the beginning. The first thing that we were doing with the calculator, that's what we're going to do. You can turn it. Okay, so remember that if we're turning a power into a root, it can be written either way. Okay? And then if we're turning a root into a power, which we're not going to be doing for evaluating, but then, yeah. There is an exception. When you have a negative power, it becomes the reciprocal, so it goes to the bottom, which we're going to be talking more about negative exponents tomorrow, but this is just a little bit of a preview. So it becomes the reciprocal, which means it goes to the bottom. So this is the rule for a negative. You just put it over, put it under 1, okay? And then we just evaluate it the exact same way. But the negative goes away once it goes to the bottom. Okay? We'll be talking more about negative exponents tomorrow. Okay? Use a little light. Alright, so let's try this out. Okay, so the first thing it says is that we need to turn it into a radical. Okay? So I'm gonna take my number here, and I'm gonna turn it into my radical. So I'm gonna make my root, and then 27. What is my exponent? 4. And what is my index? 3. Okay, so when we evaluate this, we can do this two ways. I can either take 27 and raise it to the 4th power first, or I can cube root 27 and then raise it to the 4th power. Okay, you can do either way. So let's find the cubed root of 27 first. Okay, so if we take 27, type it in your calculator, and then hit the second button, hit y-axis, and then hit 3. What do we get? 3. So then I'm going to have 3 to the 4th power. So then we can take that, say, keep that answer, then hit y-axis without the second, and then hit 4, and then hit the equal sign. And what do we get? 81. I could have also done this the other way though. I could have taken 27 and 4th rooted it. So do 27, then hit y-axis 4. And what do we get? Some really big number, right? What is it? 531. And then keep that number there. Hit the second button, hit y-axis, and then hit 3, and then hit equals, and you should still get 81. However, because 27 is a perfect cubed root, it worked out well there. So it's probably, you always want to try doing the root first, but if it isn't a perfect root, then you might want to try it the other way, doing the exponent first. Okay? So let's do the next one. So I'm going to write my equation. So, or my radical. So I have 16 on the inside. What is my power? Maybe 1. That's the top number. What is my index? 4. So I don't need to raise 16 to the 1st power because that's not going to do anything to it. So now all I'm doing is finding the 4th root of 16. So on our calculators, we can type in 16, hit second, y-axis 4, hit equals, and what do we get?
2.
What? 2. If you did not get 2, then you did something incorrect. Okay, so now let's rewrite this as a radical. So I have 9 on the inside. What power is 9 going to be raised to? 3. And what is my root? 2. Do I need to put 2?
No.
No, because it's just a square root. Okay, so what is the square root of 9? I knew that pretty quickly. 3. And what's 3 to the 3rd power? 27. Okay, so I need to take my number and I'm going to turn it into a root. So I'm going to have 32. And then what is my exponent?
2.
And what is my index? Okay, so what is the 5th root of 32? And then what is 2 squared? Okay, so we're going to break this into or make this into a root. So I'm going to have negative 64 on the inside. And what is my power? 2. And what is my index? 3. What is the 3rd root of negative 64? Negative 4. And then that's going to be squared. And what is negative 4 squared?
16.
16. Okay, I'm going to have to erase to do 32 because I don't have enough room. You guys have extra room over there. So just, if you don't have this down, please take this down. I just need a little bit of extra room. So when we have a negative, it becomes the reciprocal. So it's going to get put under 1. Okay? in this case, because that would be the number that 32 is over. So I'm just going to start off by making this 1 over 32 to the 2/5. Okay? Which then, if I were to turn my 32 to the 2/5 into I'll write that bigger. So this all goes with this one, okay? Which is 1 over 32 to the 2/5. Okay, so now if I write 32 to the 2/5 as a root, what is my exponent? 2. And what is my index? 5. Okay, what is the 5th root of 32? 2. So then that's me 2 to the 2nd, which what is 2 squared? 4. So this becomes 1/4. That's 32. Alright, so our homework, which we still have, I don't know, 21, 8 minutes. You probably get a few of them done. You need to show your work, okay? So like how I showed my steps there, that's what you need to do. So you need to do this on a separate sheet of paper. The first one is a little hard to show your work because all that you're doing is rewriting them in the correct form. So if it has an exponent, you're writing it as a root, and if it has a root, it's writing it as an exponent. So I understand that would be hard to show your work for, but the rest of them where you're evaluating, you can.